എന്തായാലും ഞാൻ ഇന്ന് ഉണ്ടാക്കും തോന്നുന്നു. അപ്പോൾ ഞാൻ ചെയ്യുമ്പോൾ ഫോട്ടോ എടുക്കാട്ടോ. ഡോണ്ട് റിലൈ കംപ്ലീറ്റ്ലി ഓൺ മീ. പക്ഷേ ട്രൈ ടു ആസ്ക് യുവർ ഫ്രണ്ട്സ് ഓൾസോ. പക്ഷെ ഞാൻ ചെയ്യുവാണെങ്കിൽ
Evangeline, mute your mic.
എനിക്ക് ചെറിയ
Evangeline,
ഇൻട്രസ്റ്റ് ഒക്കെ ഉണ്ട്.
Evangeline, mute your mic.
പക്ഷേ
Students, good afternoon. Hello. Students, can you able to hear my voice? Voice is audible?
Yes, sir.
Yes, sir.
Okay. 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 All of you, regarding the first module, we have completely seen all the topics. Okay, no topic is left out. Okay, we will try revising the module number 3. Okay, I think 2 to 3 weeks are left out. Okay, before that, we will revise everything. Okay, then for the um, forthcoming exam, there is a third interval test. Chilling. I will share the material. Okay, chilling and the freezing. Okay, then see for the case of see. Okay, students, can you able to see my screen? Hello.
Yes, sir.
Sure. Okay. Okay. All of you just listen. This is for module number 3. We have already seen, but anyway, we are going to revise. Okay. This is psychrometrics. Psychrometry means the study about the mixture of dry air and the water vapor is called the psychrometrics. Okay. If you take a dry air, its composition will be 77 percentage of nitrogen and 23 percentage of oxygen by mass. Okay, this is it is not a very exact percentage because the air contains not only nitrogen and oxygen. Apart from this, some amount of carbon dioxide will be there, but the percentage of carbon dioxide present in the air is only 0.03 percentage. Okay. Apart from this, the nitric oxide, nitrous oxides, okay, NOx, it's called the NOx. Okay, gases will be there, sulfur dioxide also will be there, and some traces of the inert gases like helium, neon, krypton, xenon, all these things are inert gases. Some amount of inert gases also will be there, but those percentage will be very, very less only. The predominant composition will be nitrogen and oxygen. That too, the nitrogen composition will be more. It will be around the 77 percentage by mass and 23 percentage by mass by oxygen. Okay. This is the percentage expressed in mass. We can express the percentage in volume percentage or a mole percentage also. For the volume and mole percentage, it will become 79 percentage. This will become 79 percentage, and this will become 21 percentage. This will become 21 percentage. Okay. Then, if you take moist air in the sense, the air will contain some amount of water vapor. That is called the moist air. So, okay. Then, in the beginning of the this lecture itself, we have seen what is psychrometrics. Okay, that psychrometry means the study about the air and the water vapor mixture is called psychrometrics. Okay. Why we are bothering about the air water vapor mixture? Because the water vapor which is present in the air that is normally called the humidity, isn't it? Okay. The humidity plays a very vital role in determining the enzyme, in determining the microbial activity. If the microorganism will grow very fast in the humid air, and if the air is dry, that means there is no water vapor content. In that case, the microorganism survival will be very, very minimal only. Okay, that's why we are studying, or that's why we are very much interested in studying about the system of dry air and water vapor. Okay, the next comes the saturation capacity of the air. Saturation capacity mean at a given temperature, at a given temperature and a given mass or volume of the dry air, it can accommodate a maximum quantity of water vapor. It can accommodate. Okay, the maximum amount of water vapor that air can accommodate at a given temperature and a given mass, okay, that is called the saturation capacity of air. Saturation capacity of air. Okay. If you change the temperature of the system I mean the dry air, if you change, then definitely its capacity to accommodate water vapor, that will change. If the temperature is more, then the dry air can accommodate more of water vapor. And if the temperature is less, it can accommodate less amount of water vapor. That is the meaning here. Okay. The next um, next is the dry bulb and wet bulb temperature. You know how to calculate the dry bulb and wet bulb temperature. Then the both the dry and wet bulb temperature can be predicted with the help of this sling psychrometer. All of you can able to see my screen. Hello, 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 students. Can you able to see my
Yes,
screen?
sir.
Yes, sir.
Okay, okay. Just I want to make sure whether I lost the connection or not. That's why I'm asking. Okay. Then see here, it's called a sling psychrometer, and it will contain a board. In the board, two thermometer will be kept. Okay, and in one thermometer, the bulb is free only. It is not covered with any cloth. And in the next one, the bulb will be covered with a wet cloth, and it will be dry with some amount of water. Okay, then and it's fixed in the board. Okay, the entire board can be rotated by using a handle. It can be rotated freely in air by using a handle. Okay, then what people used to do, they will rotate the entire system. That means they rotate the entire frame for some time in the free air. Okay, then after that only the reading will be taken. Okay, the temperature which is shown in the bulb, which is not covered with the wet cloth, that is called dry bulb temperature. Okay, and the temperature which is read in the thermometer whose bulb is covered with a wet cloth, that is called a wet bulb temperature. Okay, why we are rotating that one? Because we are trying to reach the equilibrium temperature. That's why we are rotating the handle or the spring. We are the entire frame will be rotated, okay, until it reaches the equilibrium temperature. That is the meaning here. Okay, then now you know what is dry bulb and wet bulb temperature. Okay, the next wet bulb depression. First we will see what are the definitions. It may take 5 to 10 minutes, that's all. Then after that we will go to the psychrometric process. Psychrometric process, because that is not I think that is not dealt. Okay, but anyway, today we will see about the psychrometric chart. Okay, the wet bulb depression. The wet bulb depression means the temperature difference between the dry bulb temperature and the wet bulb temperature. All of you, please wait. சார் சொல்லுங்க சார். சொல்லுங்க சார், சொல்லுங்க. ஓ, சரி சரி சரி. இந்த கிளாஸ் ஒரு 1/2 மணி சொல்லட்டுமா சார்? நான் சொல்கிறேன், ஃபாலோ பண்ணுறேன். கண்டிப்பாக தரமாங்க. DBT is the dry bulb temperature and WBT is the wet bulb temperature. Okay, the difference between the wet bulb temperature and dry bulb temperature is called WBT. That is the wet bulb depression. Okay, if the air is saturated with the water vapor at the given temperature, see that the air is saturated. We have seen the air can accommodate a maximum amount of water vapor. Okay, the maximum amount of water vapor that can be accommodated by the dry air, that is called the saturation capacity of the dry air. Okay, if the air is saturated with the air, then in that condition, the dry bulb temperature and the wet bulb temperature will be the same. Dry bulb and wet bulb temperature, there won't be any difference. Otherwise, we can say for the saturated air, wet bulb depression will be equal to 0. That's all. Okay. The next comes the dew point temperature. Dew point temperature means take a vessel which is having a dry air and water vapor. Close the vessel and try to cool that vessel. Then what will happen if you cool and you check what will happen to the phase change is there, and observe is there any phase change within the system. Okay. Then the inside the dry air and the water vapor is present, isn't it? Then if you cool up to certain level, there won't be any phase change. Phase change, I mean both the water vapor and the dry air, it will be in the gaseous form only. No, nothing will happen. Then after one point, okay, when you continuously cool, after one point, what will happen? The water vapor which is present in the dry air, that will start condensing. The first dew will be formed. Dew, the small droplet, okay, of the liquid will be formed. Okay, therefore that point is called dew point temperature. It's called dew point temperature. Okay, for the saturated air, already we have seen wet bulb temperature and dry bulb temperature will be equal. Apart from this, the dew point temperature also will be equal. Okay, all of you note down this point. This point is important for saturated air. All of you see here for the saturated air. See here, I marked a tick. Okay, the dry bulb temperature, wet bulb temperature, and dew point temperature are same, or all will be same for the case of a saturated air. Okay. The next coin comes the dew point depression, that is represented dPT. That is a short form, which is equal to the difference between the dry bulb temperature and the dew point temperature. Dry bulb temperature and the dew point temperature. The difference, that is called a dew point depression. That's all. Okay. The next, specific humidity ratio or moisture content, anything. We can all the specific humidity ratio, moisture content, it means the same. Okay, that is it is denoted as omega. It is denoted as a omega. That's all. Okay, then omega is equal to mass of water vapor divided by mass of the dry air. Mass of water vapor divided by mass of dry air. Here we have to keep the volume constant. The volume is kept constant here. Okay, therefore in short form we can write omega is equal to m suffix v and m suffix a, where m suffix v is the amount of water vapor and m suffix a is the amount of dry air. That's all. Okay, these two, mv and ma can be replaced with the help of this pv is equal to nRT. We know pv is equal to nRT, isn't it? Okay, pv is equal to nRT. Good. This n is nothing but the mass by molecular weight. That is the mole. N is the mole. What is the definition for the mole? Mass divided by molecular weight. Molecular weight into RT. We can write like this, isn't it? Okay. Therefore, I can replace for the air, the molecular weight of the air is 28.82, and the mass can be written as mv alone. Okay, and sorry, ma. And for the case of water vapor, the molecular weight is 18 and the mass is mv. That's all. We have to substitute everything. Okay, and after substituting everything, I got the ultimate expression for this. That means after using the ideal gasification pv is equal to nRT, where n is the number of moles. Number of moles can be replaced with the mass divided by molecular weight. Okay, the molecular weight of water is 18 and the molecular weight of air is 28.82. By substituting all this, ultimately I got the expression omega equal to 0.622. All of you see here, this one, the ultimate expression I got. The meaning for this expression is, see, this only I am introducing, I am writing like this. That is mv divided by ma. Now, after using this ideal gas equation, I have written like this: 0.622 pv divided by pb minus pb. Where pv is the partial pressure of the water vapor and pb is the total pressure. Total pressure means the sum of partial pressure of vapor and the partial pressure of air. Okay, put together, that is called the P B, is the barometric pressure. Barometric pressure is nothing but the total pressure. That's all. After substituting, we can calculate what is omega, where omega is the specific humidity. It can be called as a specific humidity or the humidity ratio or moisture content. You can call by any three. Okay. The next. The same thing, whatever I told you, by using the PV equal to nRT only, they ultimately got this expression, and dividing ultimately they will get this one. Okay. The next degree of saturation. Okay, then saturation ratio, then percentage saturation. The meaning is, you have a water vapor in your hand. Sorry, you have a dry air with the water vapor in your hand, and it is having some amount of moisture. Okay, good. Water vapor. Okay. And you want to compare its moisture content to the moisture content if it is saturated with the air. Okay, that is the meaning here, degree of saturation. Okay, see here, the degree of saturation is denoted as mu, which will be equal to specific humidity of moist air divided by specific humidity of the saturated air. That's all. Then here also the omega can be replaced with 0.622 pb divided by pb minus pb, isn't it? Okay, which we derived the last In the last slide, we got the derivation, isn't it? Okay, this derivation. All of you, this derivation. Okay. Whatever the derivation given, all of you wait. All of you wait here. All of you can able to hear my voice? Hello?
Sir.
Okay. This equation only I am going to use for omega and omega A. Omega S. Okay. Omega divided by omega S. That's all. After substituting, ultimately I got the expression for this degree of saturation. Degree of saturation. What is the ultimate expression I got? This is the expression which I got ultimately. See, it is given at the end of the slide. Okay. Then at the end of the slide, I got the ultimate expression like this: mu is equal to PV divided by PS, and then within bracket PV minus PS and the PV minus PV. That's all. Okay. The next relative humidity. Okay, the relative humidity. It is defined as the actual mass of water vapor in a given volume to the saturated mass of water vapor in the same volume and temperature. Okay, pi is equal to, ultimately I got the expression pi is equal to PV divided by PS. This is called the relative humidity. Okay, the next total enthalpy of the moisture. Total enthalpy means the enthalpy. We know that the enthalpy is having two parts. One is the internal energy associated one, and it is a, and second part is the work, that is the pressure volume work performed. Okay, this put together is called the enthalpy. That's all. Okay, now if you take a water vapor and the air mixture, the water vapor is going to contribute some amount of enthalpy, and the air also is going to contribute some amount of enthalpy. These enthalpy put together is called the total enthalpy of moist air. That is denoted as a H. Okay, therefore H equal to, okay, all of you just listen here. H is equal to Cp into Dd plus omega into Hg. Okay, you know what is Cp? Cp means what? All of you, Cp means what? Cp means what? Students, Cp means what? You have to say something. Am I audible? Amma? Chale. Hello?
Specific heat, sir.
That too, specific heat at a constant of pressure. We have two different specific heats. Specific heat at a constant of pressure and specific heat at a constant of volume. We do have. But here we are using for Cp value only, we are using for calculating the enthalpy of the moist air. Cp here means Cp as specific heat capacitor constant of pressure for the case of air. Into Td. Td is nothing but the drivable temperature of the air. Okay, that's all. Plus omega into Hg. What is this omega? Omega is nothing but the amount of the moisture vapor, water vapor present in per kg of the dry air, isn't it? Okay, that is omega. Okay, that should be multiplied with the Hg. That is the specific enthalpy, and that is H is the specific enthalpy of air. Specific enthalpy of air. Okay. The next day, Dalton's law of partial pressure. Okay, this principle we used it with, in the earlier slides itself. Here, what is the partial pressure? See, I have taken some vessel. This vessel contains nitrogen and oxygen. The total pressure of the vessel is because of the partial, the summation of the partial pressure of the air and the partial pressure of the water vapor. That's all. As a PA plus a PV. Okay, that is called Dalton's law of partial pressure. Okay. The next partial pressure of water. By substituting all these things, the meaning is by substituting and the partial pressure of water vapor and the partial pressure of the air, we ultimately got expression P is equal to something. Okay. Then Psychrometer, that is the laboratory scale psychrometer is there, is a sling psychrometer and a aspirating psychrometer and a continuous recording psychrometer. These are also some of the psychrometers available. Okay, this we have seen in the earlier type of stuff. Okay, then psychrometric chart. What are the various? What is the significance of the various lines? Significance of the various lines. Okay, this will be much easier. If you see these lines, this will be much easier. Okay. See here, this is the psychrometric. Okay, and in the psychrometric chart, you will be having lot of lines. You will be having all of you read that this is the actual psychrometric chart. All of you can able to see my screen. Hello.
Yes, sir.
Okay, this is the psychrometric chart, actual psychrometric chart. This is okay, and here lot of lines are there: horizontal line, vertical line, and the lines which are slanting one and curved different curved lines are there. Okay, all these things are there. Isn't it? Okay, therefore we want to know what are the significance of the various lines we want to know. Okay, see here the entire line which is present in this one, that is grouped here into this one. Okay, and see at the bottom is the drivable temperature. That too, the x-axis is increasing from left to right. Is increasing from not right to left. It is increasing from left to right. All of you see here the drivable temperature. Okay, see here, all of you just listen here. The drivable temperature. The drivable temperature increases from left. Okay, left I mean this extreme to the right extreme, that is this point. Okay, it is increasing from left to right along this line. Okay, along this line. Okay, that is the drivable temperature. Good. The next, there is a saturation line. There's a curved line at the left end. There's a curved line, isn't it? Okay. Therefore, this curved line is called a saturation line. Okay, good. And the verbal temperature, the verbal temperature lies in the saturation line only. It will lie on the saturation line only. Okay. Then, if you know the drivable fundamental temperature, first we have to draw the drivable fundamental temperature. Okay, see here we are getting the junction point of all of you. Wait. All of you see here, this is this point. I'm talking about this point. Okay, this point is the junction of a wet bulb and dry bulb temperature. Wet bulb and dry bulb temperature. That point first you have to locate. The nature of the problem is you will be provided with the wet bulb and dry bulb temperature. You may be asked to find out what is its dew point temperature, what is its moisture content, what is its relative humidity, then what is its wet bulb temperature, and specific volume and the saturation line, okay, and the specific humidity. Everything you will be asked to find out by providing only the wet bulb and the dry bulb temperature. That's all. Okay. Then see here this point. The line which is vertically upward. Not this one. Okay. This vertical upward line indicates this line. That is indicate the dry bulb temperature. That's all. You have to draw a vertical line. Okay. Until it touches the x-axis. From the x-axis, you can find what would be its dry bulb temperature. That's all. Okay. The next comes this is the wet bulb temperature. Okay. Listen. This one is the wet bulb temperature. Okay. And second thing, this is the volume. Volume is nothing but the specific volume. Specific, or the meaning for the specific volume is meter cube per kg. All of you have to note down. It will be expressed in terms of meter cube per kg. Okay. Therefore, here the specific lines are somewhat inclined. These lines. Okay, you will be having lot of parallel inclined lines like this. This will give you a specific enthalpy values it will give. Okay. Now you know wet bulb temperature, specific volume, dry bulb temperature. Okay. And from the junction, if you travel towards the right, he is talking about this one. Okay, if this is your junction, okay, good. Okay, junction of dry bulb temperature and wet bulb temperature. From the junction, you have to draw a line. You have to draw a horizontal line, that too towards the right. Okay, this will hit some point on the y-axis. Okay, that point is called a specific humidity. It's called specific humidity. Okay, similarly, what you have to do, you have to draw a horizontal line from the point of intersection of the wet bulb and dry bulb temperature towards the left. Okay, that point, and it will hit the saturation line at one point. At the point where it meets the dew point and the saturation line, that is called a dew point temperature. That's all. Okay. Then the relative humidity also we can find out. Okay. Therefore, if you know the wet bulb temperature and dry bulb temperature, from that you can fix what would be the dew point, what will happen to the moisture content, and what is the specific volume, and the saturation. On the saturation line you can find what the dew point, relative humidity, and the dry bulb humidity, and the specific humidity. Okay, all dry bulb temperature and the specific humidity all can be calculated if you know the wet bulb and the dry bulb temperature. That's all. Okay, so here these are vertical lines are dry bulb temperature, and these is somewhat inclined line. Okay, it is called the wet bulb lines, and this is the relative humidity line. It is expressed in 20% relative humidity, 30% relative humidity, and so on. Okay. The next, this is the humidity ratio, and if you as the unit for specific humidity ratio is a kg of moisture per kg of dry air. Okay. The next, dew point line. Dew point line, you have to start from the right side, and it will touch the saturation line at the left side. So, okay, that the where it meets the saturation line, that is called the dew point line. Okay. Then next, specific enthalpy. Apart from that, there is a scale for the specific enthalpy. This scale will be drawn above the saturation line. It is drawn above the saturation line. And what you have to do, you have to draw a line from the wet bulb temperature, and you have to extend or extrapolate this line until it touches the specific enthalpy scale. Okay, from that scale you can easily find out what is the specific enthalpy. Okay, and specific volume. The unit for the specific volume is meter cube per kg. All of you note down. The unit for the specific volume is meter cube per kg. That's all. Okay. Then this is the application. Okay, if two variables are given, how to find out the rest of the things. Okay. See, in the psychrometric chart, in this problem, they have given only the 25 as the dry bulb temperature and the wet bulb as 20 degrees Celsius. Okay, we have to find what is the relative humidity ratio, specific volume, and the specific enthalpy we have to find out. Okay, then see here, all of you can able to see. Hello?
Yes, sir.
Okay, all of you listen here. We know only the two data. That is the wet bulb temperature. Wet bulb temperature is here. Lot of lines will be there for the case for calculating the wet bulb temperature. Okay. Then from that you have to mention. Okay. And okay, here is the dry bulb temperature. Okay, this is the wet bulb temperature on the saturated line. Okay, you have to draw straight line from both these points, from the wet bulb temperature and as well as the dry bulb temperature. It will cut at this point. All of you just listen here. It will cut at this point. Okay, that point is the origin for so many factors to be calculated. Okay, from that point you have to see where is that point. If it is on any curved line, okay, and you have to see the value for the curved line. That will give the relative humidity, relative humidity. Okay. The next step, to find the dry bulb temperature, you have to draw a line, and not dry bulb temperature. It is a dew point temperature. Dew point temperature. You have to draw a straight line like this. Okay. Then it will touch at this point, and you have to find what is the value of this temperature at this point. And similarly, to find out the humidity, that is called a specific humidity. Okay. Then here you have to draw a line, and it should touch this. This is y-axis at the right side. It has to touch. Okay. Then from that I can find out the humidity value as 12.6 kg per kg of dry air. DA means dry air. That's all. Okay. Then this specific enthalpy, that can be calculated by drawing a straight line from the point of intersection of dilute temperature and developed temperature. That's all. Okay. The next comes the psychrometric process. I'll have to wait for some time. I'll have to wait for some time, just to have some water. Hello? Hello, students, can you able to hear my voice?
Yes, sir.
Yes, sir.
Okay, okay.
Yes, sir.
The next we will go to the psychrometric process. We will go. So far we have seen the basic definitions in the psychrometry and the various lines pertaining to the psychrometric chart. And if only the dry bulb temperature and the wet bulb temperature are given, how to collect the data, the rest of the data, like specific enthalpy, then humidity ratio, then dew point temperature, specific volume, like this, all of the data, how to get. Okay, that also we have seen. Now you are very familiar how to use the psychrometric chart, isn't it? Okay. The next we will go to the psychrometric process. We will go. Okay. The psychrometric process is important for the case of what is this? Yeah, refrigeration, the air conditioning. Okay. Students, can you able to see my screen?
Yes, sir.
Great. All of it, just listen here. The main purpose of the psychrometric process is we have to alter both the temperature and as well as the humidity ratio. The humidity, just humidity, that's all. That is the basic principle behind air conditioning, isn't it? Okay, what do you mean by air conditioning? What do you mean by air conditioning? Air conditioning means we have to alter. I did not use the word reduce or increase. In some cases we have to reduce, in some cases we have to increase, isn't it? Okay, therefore I am carefully using the word altering. Okay, therefore the process of altering temperature, humidity, and removing the suspended solid content and removing the odor, all these things are comes under air conditioning, isn't it? Okay. Therefore, how the temperature and on the humidity of the air can be altered. This can be brought by various ways. Okay, one is called a sensible heating. Sensible heating means in this case we are not going to alter the moisture content of the dry air. We are not going to alter. Just what we are going to will be doing, just we will be adding heat to the air. That's all, without altering the moisture content. Okay, the moisture content can be represented by the specific humidity, isn't it? Okay, the meaning is the specific humidity of air is not altered before and after heating process. That is the sensible heating. That's all. Okay. The next comes the sensible cooling. Sensible cooling means here also I am not changing the humidity. Just I am cooling from high temperature, low temperature. That's all, without changing its moisture content. If I cool too much, then what will happen? The moisture content which is present in the dry air, that will try to condense. Once the condensation is affected, then the amount of moisture, water vapor present in that air, that will be different. Okay, but for the case of a sensible cooling, I am not altering the water vapor content. Just I am cooling, I am reducing the temperature. That's all. This is the second process. And the third one is the humidity. Anyway, we are going to see in detail each process one by one. Okay. The third one is the humidification process. Humidification process means adding water vapor to air without changing its temperature. That is the meaning. Humidification, I am not changing the temperature of the air. The tribal temperature is not changed. But what about the water vapor level? The water vapor level I am increasing. That is called the humidification process. Okay. The next comes the dehumidification process. Dehumidification process means I want to remove the excess water vapor present in the air and without altering the temperature. That is called a dehumidification process. The next, heating and humidification. Heating and humidification, all of you see here so far. See, in general, either we have to change the temperature or we have to change the humidity level, isn't it? First case, we are not changing the humidity. That is the sensible heat. We are not changing the humidity, but we are altering the temperature. That is, we are heating. In the second case also, that is the sensible cooling. We are not changing the moisture content there, but we are cooling the salt. We are changing only the temperature, the salt. In humidification process, we are not changing the temperature or altering the temperature, but we will be adding water vapor to the moist air. More and more water vapor will be added. Dehumidification process means here the temperature is not altered, the temperature is not brought down, but without altering the temperature, just we want to remove the water vapor which is present in the air. That is called a dehumidification process. The next, heating and humidification means here simultaneously we are heating and as well as we are adding water vapor to the dry air. Okay, all of you can understand the difference, students? Hello?
Yes, sir.
Okay. The last one is the cooling and dehumidification process. Okay, cooling means, okay, we are going to alter the temperature and as well as we are going to dehumidify. Dehumidify means the moisture already present, that we are that level we are going to reduce. Then adiabatic mixing of air streams. What is the objective of studying the psychrometric process? Our objective is we have to reduce temperature and as well as moisture content. Isn't okay? The last one, adiabatic mixing of air. The meaning is we will have two different air stream with a different temperature and a different humidity level, different temperature and different humidity level. Okay. Then by mixing these two air stream, we can alter both the temperature and as well as the humidity. Okay, that is called adiabatic mixing. Okay. The next, evaporative cooling. Evaporative cooling means the cooling which is brought by means of evaporation. That is called evaporative cooling. Okay, here there will be a phase change will be there. The liquid will be converted into vapor. Okay, that is the main thing. These are some of the psychrometric charts. Okay. Okay, all of you. I will stop here, and each and every psychrometric chart I will teach in detail the next class. Okay. Sure. Okay, the time is going to be 12:30. All of you, I want to take the attendance. Okay, all of you wait. URK1.
Present, sir.
Okay, two absent. Okay, 3. Number 3 absent.
Present, sir.
You have to answer the thing, no? Okay. Number 4,
Present, sir.
5,
Present, sir.
6,
Present, sir.
7,
Present, sir.
8,
Present, sir.
9. Number 9 absent. 10,
Present, sir.
7,
Present, sir.
13,
13 present, sir.
14,
Present, sir.
number 15,
Present, sir.
16,
Present, sir.
17, 17 absent. 18,
Present, sir.
19, 19 absent.
Sir, chat box.
20,
Chat box, sir.
number 20 is also chat box.
Yes, sir.
21,
Present, sir.
22,
Present, sir.
23, 23 absent. 25,
Present, sir.
26,
Sir,
26,
Present, sir.
sir, you are
27,
Present, sir.
என்னம்மா
26 present, sir.
number 9 percent.
Number 9 network issue, sir. வெளியே போயிட்டேன்.
Okay, okay.
Okay,
26,
sir. Thank you.
56 absent. 27
She's present, sir.
is 26%.
Yes, sir. Sir, 26 also present, sir.
28,
Present, sir.
29,
Present, sir.
30,
Present, sir.
okay, 30,
Sir, Hussein has network issue, sir.
okay, 30, okay, 31,
Sir, present, sir.
32,
Present, sir.
33,
Present, sir.
34,
Present, ma'am.
35,
Present, sir.
36,
Present, sir.
37, 37 absent. 38, 39,
Present, sir.
40,
Present, sir.
41,
Present, sir.
42,
Present, sir.
43,
Present, sir. Sir, 17 is also present.
17, I will check it. Okay, 44,
Okay, sir.
Present, sir.
45,
Sir is present. You got logged out.
okay, 46,
Present, sir.
47,
Present, sir.
48, 48 absent.
So she got logged out.
49,
Present, sir.
50,
Present, sir.
51,
Present, sir.
51, sure, okay, 52,
Present, sir.
okay, ma, okay, 51, okay, 52, okay, 53,
Present, sir.
54,
Present, sir.
55,
Present, sir.
56,
Present, sir.
57,
Present, sir.
58,
Present, sir.
59,
Present, sir.
60,
Present, sir.
61,
Present, sir.
62,
Present, sir.
63,
Present, sir.
65,
Chat box, sir. Chat box.
67, 67,
Sir.
68,
Present, sir.
69,
Present, sir.
70,
Present, sir.
71, 71 absent. 72,
Present, sir.
73,
Present, sir.
74,
Present, sir.
75,
Present, sir.
76, Hello, 76.
Present, sir.
76. Okay. 77,
Present, sir.
78,
Present, sir.
79,
Present, sir.
80,
Present, sir.
81,
Present, sir.
82,
Present, sir.
84,
Present, sir.
85,
Present, sir.
86,
Present, sir.
88, 88, absent. 88, absent.
Yes, present, sir.
89,
Present, sir.
90, 91,
Sir, she just logged out, so network issue.
okay, 92.
Present, sir.
Okay, okay, all of you can leave. We will see tomorrow also the same time table it seems. Okay, tomorrow we will meet. Okay.
Thank you,
Okay.
sir.
Thank you. Huh?
Thank you, sir.
Thank you, sir. Thank you.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Thank you.
Sir, FP026%, sir.
26 Lokesh. Okay, I give.
Thank you, sir.
23 is present, sir.
20.
Sir, 23.
Why you did not answer?
No, sir, he got locked up, sir.
Check.
Sir, roll number
Sir,
12,
FP 15%, sir. 1
Yeah, I give. Okay, good.
sir. FP 002 present, sir.
0, 0. Huh? Okay, okay. All of you can leave.
Thank you, sir.